Welcome to a powerful new module, Threads. Up until now, our code has executed sequentially one instruction after the other. But modern applications must handle multiple tasks simultaneously, like responding to a user interface while downloading a file in the background. This concurrency is achieved through threads. 1. Process versus thread. To understand a thread, you must first know a process. A process is an independent instance of a running program, such as your Python interpreter or a web browser. Processes are isolated. They do not share memory. A thread is the smallest unit of execution within a process. Multiple threads within the same process share the same memory and resources, making communication and coordination much faster. 2. What is multithreading? Multithreading is the ability of a single program to manage and execute multiple threads concurrently. This concurrency is crucial for tasks where one part of the program is waiting for an external operation to complete, like network input or disk access. While one thread waits, the operating system may switch control to another thread, keeping the CPU busy and the application responsive. 3. The Python threading module. Python provides the threading module to create and manage threads. We will use the main thread class from this module, along with methods like .start parenthesis to kick off the thread's execution. We will also explore functions to identify which thread is currently running the code, which may be useful for debugging. To summarize, threads enable concurrency by sharing resources within a single process. Our next lecture 26.02, Main Thread. See you there.